trying to find determinants. Determine the determinant. Question, how do we determine the determinant of a 1 by 1?
It's the thing in the middle.
It's the thing inside. Good. We like that one, right?
Yeah, it's simple.
How do we determine the determinant of a 2 by 2?
I give up.
Oh, it's
Main.
minus
Good.
main
Main
diagonal
minus
minus the other
opposite. You want to cut it short because you're lazy, just say main opposite, and then it kind of works. Okay, main minus opposite. 3 by 3. There's a trick. Main minus opposite. But
Oh, great.
we're learning the way that works for 3 by 3, 4 by 4, 5 by 5, 10 by 10, etc. So, were you able to keep up all the way to us getting the 14 that we had done with the trick on the page before? Kind of. What was the most annoying part of the problem? I would say probably rewriting it 3 times. So if we can get our brains trained and not need to rewrite it 3 times, well then life will be nice, right? But if worse comes to worse, by rewriting, does it make sense how I set up the solution? Could you repeat it?
Yeah.
Maybe. Question. In order to solve, I used one entire row, right? I used the 0 and the 2 and the 1. Here's something you're going to learn today. You can choose any row, any column, no diagonals. Any row or any column, as long as you use every single entry in said row or said column. Thinking about circling that entry, crossing its corresponding row and column, and taking the determinant of what remains. Assigning to it its corresponding sign in our little sign trick chart up to the right. Now, we need to make the description a little bit more technical than that. A little bit more technical. Now, hold on. Here's like a super technical way of saying it. You don't have to write this down, except this technically is the formula for how to find the determinant of any size matrix. Specifically, useful for 3 by 3s and above. Because 2 by 2s, main minus opposite, so much easier. What does the paragraph say? Even though there is that formula in the middle, as long as we have, number 1, a square matrix, then the determinant is the sum at adding together the entries in any row or column. That's what I said earlier. You could choose any row or column. Multiplied by their respective cofactors. What are cofactors? And the process is called expanding by cofactors instead of the main minus opposite trick. And this works once again for 2 by 2s, but that's too hard. Main minus opposite is easier. 3 by 3s, 4 by 4s, 10 by 10s, etc. Now, once again, even though this brings in a lot of vocab, we're actually going to talk about the vocab on the next page. This is the formula I kind of want you to see. So you take the entry of a row or column, and all the other entries in said row or column. This one is using a row as an example. And you have to multiply those entries by something called a cofactor and add them all together to get the determinant of A. This is the notation we saw yesterday. So let's see what all these terms are referring to. Okay. I'm trying to let you guys know what these terms are, so you're going to see it just a little bit. Just a little bit in homework. So what are we doing trying to find determinants of 3 by 3s or higher? How are we doing it? Well, let's learn some terms. There's this thing called a minor. And I said it yesterday, but you probably didn't get a full grasp of what a minor is. The minor is the resulting part of the matrix we're finding the determinant of from ignoring the nth row and nth column of a certain entry. AKA, the minor was the leftover part that we put into a determinant yesterday. That's just the snazzy name. The minor is the leftover part that we put into a determinant yesterday. The notation is m sub m n, meaning right here where it says m sub 1, 1, What row, what column did we ignore? We ignored the first row and the first column. We ignored the intersection of A sub 1, 1. You notice the 1, 1 of A matches the 1, 1 of M. So the 1, 1 means ignore the first row, ignore the first column, take what's left, or put it in a determinant. Okay, so the minor. What's left from ignoring a row or column? Finding its determinant. Cofactor. To be honest, he's the only other term we're really going to stress about. Cofactor says take the minor. And choose to put with the minor. Maybe instead of doing 1, 1, I'll say n again. The cofactor says take the minor that's been formed and put either a plus or a minus with that minor based upon the alternating sign chart that you saw me make. Now guys, you don't have to draw all these alternating sign charts. We're just going to say, hey, they all start with what sign? No matter what size you have.
Plus.
They all start with a plus. And how do you get to the next one going on a row? Alternate. Alternate, 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 however far you need to alternate. Whatever the size is of the original matrix you're dealing with. How do you go down? Alternate, 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 alternate. Right? How do you go across? Alternate, alternate, alternate. Just make sure they're all alternating and you're good no matter what size matrix you're looking at. Start with positive and then alternate. That's all you need to remember. Start with a positive, then alternate. So cofactor says take that minor, take that remaining piece from ignoring, and ignoring, find its determinant of the remaining piece. Cofactor says attach with it a plus or minus based upon the location of the original term that caused us to ignore the row and ignore the column that the minor came from.
So if you crossed out the 2, or if you circled the 2, and then everything would change signs to negative.
Exactly. And don't say change to a negative, say put in a negative times all the rest. Does that make sense?
Yeah.
Can we go back and look at that example from yesterday and see if this kind of makes sense what we did? This example. You saw me making minors. You guys see the minors right here? Those are the minors. Formed by crossing out rows and columns, crossing out rows and columns, crossing out rows and columns. You saw me use the formula and multiply the entry, the circled entry, by each of those minors. But the formula doesn't say just a minor. The formula says we need cofactors, aka we didn't just use the minors. We also attached these little signs on the outside of the minor and the term. And where did those signs come from? This minor, right? If we come here, this minor came from this. That went with 0. 0 is in the place of a positive. Does that make sense? So that positive is what got put into the term, or the expression for that piece, that minor. This minor came from the 2. The 2 is in the negative position, which is why a negative is what was put on the outside. And then last but not least, let me go ahead and get my cursor. This minor came from the 1. The 1 is in the positive position, which is why the positive is what we put down below. Does that kind of make sense? So let's go and see if we can repeat the process. Now that we've at least seen the formula and heard the terms. Written down a few details about the terms. Just kidding. Hold on, pause. I forgot there are a couple problems in homework that actually don't have you find the determinants. They just have you find the minors and the cofactors. This is an awkward 2 by 2. Do I have another one on the next page? We can use this as an example, though. We can use that as an example. I know it's not the best thing ever, because it's not the more complicated problem, but it's still good to get the idea down. We're going to find the minor of 1, 1, the minor of 1, 2, the minor of 2, 1, and the minor of 2, 2. There's technically a minor that goes along with every element in a matrix. That's for letter A. Then we're going to use those minors to find the cofactors of 1, 1, the cofactor of 1, 2, the cofactor of 2, 1, and the cofactor of 2, 2. Remember, find the minors first, attach some signs to get your cofactors. What does 1, 1 stand for in a matrix and foundation? Row 1, column 1. Who's that? So I look at 0, and what do I use that 0 for? Cross, cross. Who's left? Oh. Well, that was kind of easy. Question. What's the determinant of a 1 by 1? Got it. Okay, well, that's not too bad. So what if I go to 1, 2? Who do I cross cross? Who do I have left? What's the determinant of 3? Nice. So now try to visualize without actually circling and cross crossing. Some of you weren't circling and cross crossing anyway. M2, 1. Who's the entry? 3. Cross cross. Who's left? 10. Determinant of 10 is 10. 2, 2. Who's the entry? Negative 4. Cross cross. What's left? The minor is 0. Determinant of 0 is just 0. So what does cofactor do besides what the minor's already done? It says, think about the signs that match to each of these positions. Where do we always start? So what would the next one be as I go across the row? And then as I go down the next row? Careful. You see why?
Yeah.
So I need to go alternate positive to negative, alternate positive to negative. I need to make sure it alternates both ways. And then positive. Does that make sense? Okay. So what sign is going to go with my first cofactor? Because my first cofactor goes along with this one, right? So I could say I need to go ahead and attach a positive with, and here's where it gets a little weird, with the negative 4. Well, what's a positive times a negative? A negative. Didn't change. Nope, it didn't. Okay, so what if I look at minor 1, 2? Looking at the 10, what position is that? A negative. So what sign am I going to put in down below? A negative. But what am I putting the negative with? A positive 3. Well, what's a negative times a positive? So it flipped the sign. Exactly. The negative flips the sign of whatever is already there. The positive keeps the sign of whatever is already there. If you guys follow the pattern, find me the next 2 cofactors if you have not yet already. Although the last one is kind of easy. So 2, 1 goes with a 3, which goes with a negative, so I put a negative in, and what's a negative times positive 10? Negative 10. As I go to the next one, we don't have an orange. Awkward, it's going to be yellow. The negative 4 goes to the positive, so I put in a positive, but a positive with 0 is just going to be, well, that's 0 no matter what. Does that kind of make sense, kiddos? The difference between minors and factors. Minors, we circle something, we ignore its row, its column, take what's left, determinant. Okay. So we worked with our vocab. Let's see if we can find a determinant. This is what I was leading up to. Now, even though in homework you're gonna have maybe one or two that says do it 2 different ways, and if you do it 2 different ways, they should be the same answer because you can use any row or any column to find a determinant. Let's just save time. We're in class. We've already done one. Can you guys look at row 2, look at column 3, and see which one's numbers you like better, and let's just pick that one. 6, 3, 1. We have options. We're either choosing him. We're just going to choose one for class for examples. Do we like his numbers better or his numbers better? The row or the column? Okay. That's what I thought you guys would say. It has a 1 and it doesn't have any negatives. All right, so let's just go ahead and for sake of example, I want you guys to see, can you work along row 2, piece by piece, forming determinants, or I should say minors, attaching signs to them, cofactors, multiplying them by the entry. Can you follow the example up above to find the determinant? Now I'm going to quietly, silently, in 30 seconds start solving it. You can follow along with, if that's a little too intimidating. But if you're like, no, I think I can follow the pattern, why don't you start? I'll tell you when I'm starting. You can double check or you just keep going and double check at the end. Sound good? Ready, set, go. You might not need to write it 3 times. I'm writing it 3 times so you can see my whole process because I'm not going to explain what I'm doing. Once again, you don't have to write it if you can visualize it. Give you guys a second to check out what I did, try to show you clearly where everything came from. I used my term, formed my minors, attached the sign to the cofactor. All in hopes of finding. Ah, good catch. So who should I have highlighted instead? Did anybody else make that mistake?
Yeah.
Gotta look and see where everybody's coming. We hadn't done a second row yet. It's okay, it's okay, it's okay, it's not gonna change your mind. Right? Does that correspond now with the terms that I had? Does that make more sense? Negative, then a positive, then a negative. Make sure we correspond it, right? Now, wait. How do I keep going? Oh, sorry. This was all in hopes of doing determinant of it. Oh, we'll see. The worst we'll do is a 5 by 5. Question. How do I keep going?
Find a determinant.
Yeah, these little absolute values mean I need to do the little determinants. But if they're 2 by 2s, it's just main minus opposite, right? The main is from left to right. Upper to lower. Think the identity matrix is that main diagonal of ones. So, negative 6 times, I'm going to go pretty quick. Negative 32 minus negative 14 is negative 32 plus 14. Plus 3 times 24 minus 8. Minus 1 times 21 minus 16. Negative 6 times negative 18. Plus 3 times 16. Minus 1 times 5. One oh 8 plus 48 minus 5. Which should end up equaling 151. Now someone cool out there was like, psh, I can use my calculator to check. Right? Was 151 the right answer? David had faith that someone tried it. Oh no! No one checked it with their calculator.
What, you want me
Austin's
to
checking it now. Cool.
No, it's one.
Oh,
you just-
Ricky checked it already. Perfect. 151. Austin's gonna double check.
Is it
Do you have any
the
questions?
corrections?
Yes. Do you have any questions on the example? How many of you guys are like, I think I like rewriting it sometimes?
Kinda neat.
Do it. It works. It works. It keeps you honest, right? How many of you guys like shortcuts you're gonna try to not write freehand? Most of the rest of you aren't doing problems. No, you're not helping. I'm trying to figure out what you like. Do what you need to. Maybe in homework you'll get to the point where you don't have to write them, but if you do, there's no shame in that, okay? No shame at all.
Except for the eternal shame of being.
Can
we do it?
I quit.
Let's do
question.
it. I believe.
No. Question. Which row or column?
Doesn't matter. I
Doesn't
guess
matter.
technically the third
Third
row.
Third what? No.
Third column.
Yeah. Why am I saying totally add a third column?
There's 2 zeros.
Why are 2 zeros going to be good?
Because 2 zeros.
0 times anything is going to be 0. We don't have to do the whole binary thing.
So we just gotta like choose. You get to choose a row.
Pretty easy.
Yeah.
You just gotta match up composite.
Now, hold on. Wait. Without rewriting, can you guys figure out what I'm going to put together with 6? A 3 by 3. David, go ahead.
So instead of, if we were to write it, we have to write it 4 times.
It would be fun.
It would be not,
But couldn't you kind of use the first one as 1 already and just write it maybe one other time?
Yeah.
And then that's why we want to pick something with lots of zeros, because then life will be a lot nicer. Okay, for those of you guys that do need to be writing it, I'll write it one more time. But the nice thing is we only need 2. We only need 2. Because we're going to use the 6. We're going to use the 3. And then we're going to say, booyah, the zeros won't matter. What? Let me show you.
Well.
So get the process down, like row reducing.
Is it okay if we put the 3 into the matrix? It's easier. Put the 3 to 6 in the matrix.
I could do a 0, I could do a 0, but you guys have these, do you see how 0 and 0 are just gonna all cancel out? It's a lot easier than it could have been. Looks like tic-tac-toe, but weird. Anyway. What am I missing? What am I missing? Signs. Yeah, I need the signs. Remember, positive, negative, positive, negative, negative, positive, negative, positive. Which ones do I need? I think I just need, right? Just the positive and the negative. So I'm assigning a positive and I'm assigning a negative. Did I match it up correctly this time? Awesome. It's okay, learn from mistakes. Get it right the next time. Oh, wait a minute, the zeros cancel out, that's all well and good, but I still have a 6 and a 3 with 3 by 3s. What's my next step? What's the next step?
Oh, you have to do it again.
Yes, you have to do it on the 3 by 6.
Exactly. I can't do main and opposite unless I want to do main, opposite, opposite. It might be easier to just do the process. Meaning, ready? 6. A positive 6 is going to get multiplied by. Do you guys like this one best? I do. He has 1s in them. I like that better.
Yeah, I see it.
Cool. Hold on. Do you see how if we were to do our signs, couldn't we add in? Do you guys want to do the signs this way? Maybe it's easier.
No, so.
That's gonna be too hard.
Yes.
I'm gonna attach a negative and a positive and a negative. I use the new matrix to do the signs. So I'm gonna go ahead and have a 1 with an attached negative because of the cofactors. And what's gonna be left once I cross the 1? So anybody see the 7, 6, 7, 7 that's left once I cross? I'm going to attach a positive to the 5. What's left with him?
2, 6, 3, 7.
Yeah.
What is this?
Because with the 5 we cross. Who's left? 2, 6, 3, 7.
2, 6, 3, 7.
You're welcome. Then the minus. It makes sense. You just have to be careful with the process and not
Trust the process.
trust the process. But work carefully with him as you're getting used to it.
It's 2, 2, 7, 7, right?
2 negatives.
Yeah, she's always like, let the problem.
Here's the struggle. Why am I not doing a negative?
Because it has an outcome.
Negatives are only for the green or only for the cofactors. So maybe some of you are like, I don't like those greens, they're messing me up.
What do you mean? Wait, what? So what happens?
People thought the negative was supposed to go with the 7. And I understand that. Like, I probably get confused with that at some point too. So if you don't like that, you can always remember off to the side.
Just do it.
There you go.
You
See how I
stop
said
thinking about it.
negative, positive, negative, is that safer? Probably. Okay. What am I doing next?
Just stop thinking about it, and just do it.
Do you do AB?
Don't you do the same thing for 3?
Yeah.
1, 5, 1.
And I like the 151, right? But hold on, the matrix is a little bit different. Do you notice?
Yeah, 2, 6,
So I can't steal the exact same things. But can't I steal the same negative, positive, negative?
6, 2, 7.
Oh, I'm running out of room. Can I write small?
This is not bad.
Too much stuff, not enough space.
I got it. Don't even try. Really?
Yes, I made that right. I looked there.
What'd you say?
Not too much
6,
stuff.
7, 7, 7.
Okay, stop. Focus on what's important. You guys, the smack talk. You're gonna do the death of me.
Oh, you should have been there long ago.
Oh, it's so close, guys. Look at this.
I'm almost
2, 2, 3, 7.
Let's start to get.
That's your as important to learn multiplication tables.
Oh yeah. Oh yeah.
I mean, besides the SAT tomorrow.
No, that's it.
no.
Oh, I have the SAT tomorrow.
Saying
You said that yesterday.
River, which one?
Please tell me you didn't just remember.
Well, I mean, I
jeez,
SAT.
SAT, what?
Tomorrow. I just don't want to. I haven't studied. What?
Which are you going to?
What?
Where are you going to?
Lamar High School.
Alright, got it.
Going to Compton.
Guys, how do we finish them?
Did you get your final answer?
Then you plug in the plus negative and I like that.
Can I multiply my little 6 in? Is that okay? Save me room.
No.
I'm running out of room.
Or you could do that.
Okay, 49 minus 42.
You can
7.
do that. Legal.
Yeah, because it's the outside. It's the outside.
That's what I'm saying.
So then 30 times 14 minus 18. Someone double check my mental math along the way. I think it's negative 4. Then
How'd you
negative
get
6 times.
7?
Isn't
49 minus
49 minus
Oh,
42.
the you. Oh, okay.
14 minus 21 is negative 7, right?
No, no.
Minus 3.
We're working out your mental math for tomorrow. You're welcome.
Yeah, this is.
Plus 3 times 42 minus 14. 28.
Yeah.
Minus 15 times 14 minus 6 is 8, right? Plus 3 times 14 minus 18, negative 4.
Ouch. My friend 18.
Oops. I just totally switched the page without meaning to. I apologize.
One little mistake.
One little mistake. It's true.
Let's see a horrible.
Hey.
Do you give tests
Every
points
choice
during
you
the
make, gotta watch out. Gotta watch out, my friend. Not that you can't make bad choices in the sense of
Well, I got.
there is grace
Wait,
for all. Uh-oh, did I do a math mistake?
The very end.
At the
14 minus 18.
I didn't have.
The last one. Yeah.
Oh, did I write something wrong when I was trying to squish it in?
what?
Is it a 6? It looks like a 6.
Yeah, I didn't.
Is it 2637?
Why isn't it? Isn't it?
So then 14 minus 18? That's it.
Oh,
One
distributed.
Yeah, distributed.
Okay.
That I didn't get that.
Is that 81? No, that's not 81.
Let's see if I get the same thing.
84. Minus 8 sets of 15 are 4 sets of 30. That'd be 120, right? And then minus 12. Those cancel. Negative 240, negative 252, plus 84. Take away 52. I think so. Double checking though. Yeah. Austin, you double checked it?
Yeah.
Haha! Guys, look at that! The mental math comes through every now and then. Good news is, I don't think any mental math in the SAT will be any harder tomorrow. Mental math.
No.
The concepts might be a little different. Alright. So, I think we've graduated. We've gone from a 2x2, well, we went back to a 1x1, then to a 3x3, now to a 4x4. You guys ready? Let's see, can we do a 5x5?
No, we can't.
No, I don't want to though.
Are you sure?
Yeah.
Okay, how about a special 5x5? How about a special 5x5?
How many zeros?
A lot.
I thought so. Okay, maybe
Party
I'll.
pooper.
Maybe I'll do it.
No.
Let's find the 0, 0, 0, 0.
Is everything else gonna be 0?
Yeah.
Yay!
That's pretty nice.
I'm still not gonna do it because I'm out of money.
Oh, that is so off.
What the heck?
Are you gonna put like one
Please.
five?
We're doing like a 5x7.
There's zeros or.
Stop judging.
If I do this, can I get credit?
We're all gonna do it,
No,
David.
nobody's getting.
I'm
extra
ready.
credit.
You ready?
You know.
I'm gonna choose.
No, get the one
Column
with
one.
the 2.
Wait, is that 10 on the bottom? Or is that a
Just saying.
Doesn't 5 have a positive because it's on the upper left?
yeah?
What's left?
much is it?
Woo! Now what do we do?
Now we do
Plug it into your calculator.
Now we do the 4 0.
No, and then you have to do.
Isn't the 5 going to be positive? And what's left?
3 0
And you have to
You should do
I
it.
5 times 4 times 3 times 2 times 10. That's not healthy.
Wait, seriously? It's really that cool?
So stupid. This isn't much
Do it
of a
again.
5 by 5. Dude, what
You
if,
get
what
1
if
by
you
1.
just gave us like a 10 by 10 and it's like, alright, that's your final. Go to work.
Oh,
Dun,
can
dun,
we
dun,
do
dun,
that
dun.
for our final?
What's the end up being? Yay!
Dude, our final
But
just.
only because all the other entries were 0.
Can we do that? for
Yeah,
our
give us a
final?
10 by 10 and just say, alright, go to work.
That's it.
We'll see.
Final.
That along with the
It'll
usual
be fun.
reproducing one.
It'll be so fun. Yeah, so much fun.
Hold on, don't do
It
that.
wouldn't even
20
be
times
fun
3
if
is
they were
60,
all
6 times 2
zeros.
is 121, 20 times 10 is 1200. Done. Dun, dun, dun. Oh, wait.
Thanks.
It's a 2 by 2. What do we do?
You just added variables, so I quit.
Wait.
It's taking
Come
more
on,
than
you're
3
not
minutes.
faint of heart.
I'm waiting.
Oh, I got it.
Still waiting.
X equals 2.
How?
Cause.
Okay. It's a determinant. How do I find a determinant?
Magic.
Oh,
Main times
yeah.
other thing.
What would main be?
Yeah, that thing.
2x minus 20.
No,
foil.
foil. Don't kill
No,
me,
no,
puppy.
just square things.
X
Minus.
minus X plus minus.
Wait, does that make sense?
Yes.
Distracting. X plus 4 times x minus 5 minus negative 14.
X squared minus
That's not bad, right? Then we just FOIL stuff, yeah. X squared minus x minus 20 plus 14. X squared minus x minus 6 equals 0. We like these foiling
3 and
ones.
2. Oh yeah.
Thank you, algebra teacher, if you can factor. X equals negative 2 and 3. Dun, 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 dun.
Wait, so he was actually like right?
He said 2. He was kind
Oh.
of, sort of, he had a 2, although he's ignoring us right now. Jason, wakey wakey. Okay, so, now we're done. Because this one says, how do you use your grapher, and we already figured that out. So,
You just. Jeez. Man, but you notice how much quicker typing into your calculator is?
it's brutal. 8.5. We barely get to start them, but that's okay. We're going to kind of shortcut some stuff
What?
for Monday to get the highlights.
This is clearly matrix division.
Guys, Kramer's rule. Super cool and all. Kramer's rule. Super cool and all.
Define cool.
It's actually another way of solving 4 systems of equations, but for sake of time, you guys are writing down section 8.5, applications of matrices and determinants. For sake of time, I'm saying no.
Okay.
All of it?
No, just the Kramer's rule. He's one of 4, one of 5 applications in this section.
Yeah, go
So,
away,
you guys
Kramer.
are writing down the title. I'm saying no, just in case you're gone on Monday or all of next week or all. I'm saying no to Kramer's rule.
Just in
Just
case
say
Kramer
no.
thought he was
It's
cool
But
enough.
wait, pause. What does that mean in homework? Are there some Kramer's rule problems?
Yes.
Skip them.
You can skip the Kramer's rule ones.
Burn them.
Okay? So, going back. Applications of matrices and determinants for skipping Kramer's. All together. It's not on the test, it's not in your notes, it's not in homework. Actually, it is, but you're skipping
Just do
it.
it.
What was 8.4
The
called?
4 other applications. Starting with
Mr. Could you do filming?
area of triangles.
Yeah.
Yeah, it's hidden down there. It's like this little baby red.
Is 8.4 determined?
Yes.
What?
Now, pause. Can 3 points determine a triangle? As long as they're not on the same
plane.
What's the only way that they can't make a triangle? If they're on the same line, that's a really awkward triangle, right? But as long as I have at least one point that's not collinear, I can form a triangle out of any 3 points. But finding the area of said triangle with 3 points is going to be quite difficult unless you plug into a really cool formula that says, hey, no big dealio, give me your 3 points, fill in ones, find the determinant times 1/2. Alright, well kids, we'll finish 8.5 on Monday. Including messages. Bye guys.
Including.
Yeah, you're gonna give us coding messages.
Okay.
Oh yeah, you're gonna get yesterday we learned how to
Misty, the thing is, it's like the
determinant
worst.
with the name. You have to put your matrix in.
Say Mrs. D.
Nobody who's serious is gonna try to encode something using matrices.
And I will miss you.
Really?
I didn't know you guys were leaving and stuff. Alright, sounds good, kiddo.